Back to another video, guys. We are doing differentiation of functions with two or more terms. In the previous session, we considered those basics and middle level questions. If you're not sure how to work with that, just make sure you watch that video and try to practice by your own first anyway. And today we're gonna go through exam style harder questions. Right now, that's gonna be this question for now that you can pick up from the previous video. So try to pause the video, try to do by your own if you're ready for doing that. And let's get started explaining. So what do you need to do in question A? You need to find all the terms of the binomial expansion of fx. So there are two ways. Either you're gonna use the formula, that's right now I'm gonna show you how it works. So for binomial expansion, you can say that your function fx is simply a plus b to the power 7, right? That's the general binomial expression. So where a is your first term is x and b, so we always use positive sign, right? We add in those binomials. And that's why b is going to be -2 over x. Okay, so you use binomial expansion for that. And I just remember here, so binomial expansion for fx will work like using sigma notation. That's going to be the sum, so sigma stays for the sum. A to the power n minus, too early for a. So first the binomial coefficients and choose r, where r goes from 0 to n, okay? And with times a to the power n minus r and b to the power of r. So that's general formula using binomial expansion. If you're not comfortable with that, however, you can use your GDCs, right, in order to calculate those coefficients. Alternatively, you can use Pascal's triangle. So Pascal's triangle. If you're not sure what it is and which way to choose, please watch the video dedicated to binomial expansion. You can find it on my channel and in the subsection in the playlist for A-level maths, okay, binomial expansion. So if you know how to do that, and I'm gonna use that first way, because in this case you need to find all the terms, and I think it's more faster to do using calculator and calculating those coefficients. All right, so but in general case, what I'm gonna say that your binomial coefficient will represent the following. So that's going to be n factorial over r factorial and the difference n minus r factorial. Okay, in our case, we'll have the following formula for our particular case. So fx is going to be equal to the sum, r goes from 0 to 7, right? Our maximum power is 7. So coefficients is 7, choose your particular r. Instead of a, we put x, so x will goes to the power 7 minus r. Okay, and b is going to be -2 over x to the power of r, where r is the current index that goes through 0 to 7. All right, so if I just show you probably the first two, okay, how it works, and then I'm not going to write all those terms. I will only write the final answer for that. Okay, so right now what I'm going to do, I'll just show you the first 3 terms. Okay, so the first one is 7 factorial, so r is 0, so that's why it's 7 factorial over 0 factorial and over 7 factorial. Okay, and because 7 minus 0 is 7. So make sure you remember that 0 factorial is always 1. It's not 0. It cannot be 0. Okay. And the first power for the x is 7, while -2 over x will get the power 0. Simply 1. Okay. So the next term, So plus 7 factorial over 1 factorial and over 6 factorial, okay? X will go to the power 6 and negative 2 over x will get the power 1, okay? And as I promised, I'll show you the third term, 2 factorial and 5 factorial. X will get the power of 5 and negative 2 over x will give you the power of 2. Okay, so that's, of course, we need to add more and more. So until we reach the last term, which is going to be negative 2 over x to the power of n, which is in this case 7, okay? So, but I'm not going to write. So that's for now. That's all for now. And as I promised, the final expression for f from x for the part A with all coefficients calculated is going to be, so that's pretty long, but anyway, x to the power 7 minus 14x to the power 5 plus 84x cubed and minus 280x plus 560 over x minus 672 over x cubed plus 48 and over x to the power 5. And finally, we'll get the last term, minus 128 over x to the power of 7, okay? That's all binomial expansion, and as you noticed, so the power is not decreasing by 1 because you have x in the bottom part. So that's why, for example, when you start multiplying, let's say here is still x to the power 7. For example, here x to the power 6, you multiply by negative 2 over x. That means 1, 6, and x in the bottom part will be cancelled, leaving you with x to the power 5. So that's why the second term will have x to the power 5. And that's how it works, okay? So we completed A, and now for B. So for B part, we know that in our case, if ax is quite big number, so that's keywords, so that for any x to the power of n, when n is positive, z plus is positive integer. So this is, so positive integer, okay, positive integer. The reciprocal number of that x to the power of n is very small. You need to show that f derivative from 0 is negative 208. Okay, so many students notice that that's going to be here. So that's your term. Okay, but it's too early because right now I'm going to show you. First, let's discuss what does it mean if x is quite a big number. That means, remember the limit series. So x tends to positive infinity because it's quite big. So for any x to the power of n, it's going to be x to the positive power. But if x is negative, so that's for x more than 0, and or it tends to negative infinity if x is very small. But in both cases, x to the power of n is quite big, right? So it's going to be plus and minus infinity. What about the reciprocal? So the reciprocal is simply 1 over x to the power of n. And of course, using the limit theory, it tends to 0, okay? It tends to 0. So when x is quite big. So because you'll have something 1 over positive or negative infinity, that means it's anyway 0. Just remember the limit theory, or remember how you explore functions for having asymptotes, okay? We actually gone through limit theory when we discuss derivatives, okay? So that means all those terms will be negligibly small, right? So because every single term is actually reciprocal, so that you can neglect all those terms. And you left, in this case, you can say that when x tends to positive or negative infinity, you'll get the following. Fx, in this case, is going to be equal x to the power 7 minus 14x to the power 5 plus 84x cubed and minus 280x. Okay, so in this case, what we're going to do right now, we need to show that f prime, so that's why we need to calculate the prime, f prime, or work out the prime. So we differentiate that and we'll get 7x to the power of 6. So minus 5 times 14 is going to be 70. 70x to the power 4. 84. So 84 times 3, 252. So plus 252x squared. And on top of that, so right now, I'm just squeeze a little bit. Okay. And on the top of that, we will also have minus 280, okay? So that's our derivative, and right now we just plug in 0. So now we're looking at our derivative f prime from 0, and everywhere we just simply plug, instead of x, every single x, we plug 0. So that's why that's going to be negative 280. So that's why we show that. And that's the solution. That was challenging maths. Hope you like that. For other topics and subtopics for A-level, just please explore of the section on my channel for A-levels stuff. And also don't forget to visit A-level zillions classes. If you're new here, please subscribe. Don't forget to smash the bell button, and see you next time. Peace out.